Okay everyone, in my last video I said I had some more tricks for you. I guess we'll start with turning a diameter for square or hex. I'm sure everyone's run into that. If you wanted to make a bolt with a hex on it or one with a square, what diameter do you start with? Well, it's pretty easy. Got some more equations here. None of this stuff's going to be groundbreaking or show you the secrets of life or nothing, but they will come in handy. When you want to make a square, what diameter do you start out with? Well, it's real simple. Square, you take the dimension across your flats times 1.414. So an example would be 7/8 square you want to make. Take 7/8 times 1.414, that'll give you a 1.237 diameter. So you need a diameter to start off of 1.237. Hex is just as simple. It's the 875 across the flats times 1.155 gives you a 1 inch 10. Very simple. Say you were to cut a hex into a shaft such as this, you would start off with the 1 inch 10 and then cut your 875 hex in there. Real simple, easy, nothing groundbreaking. Let's see what else we got here. Okay, with feeds and speeds. Cutting steel now, dry. When you're using carbide, a good round surface feet per minute is 400. That's 400 surface feet per minute. With high-speed steel tools, 100 surface feet per minute is a pretty good round number to cover all the steels. Obviously you have to lower them for really hard steel, and something that's like a leaded steel or free machining, you could raise them surface feet up a little bit. So now that you know what surface feet you want to reach, this is cutting with tools now, not grinding. If you want to know your RPM, you take 3.82 multiplied by the surface feet per minute, depending on what material you're cutting and what tool you're using to cut it with, divided by the effective diameter. Alright. If you know the diameter you're using, and you know the RPM you're using, and you want to know if you're around the surface feet per minute you want to be in, you take your effective diameter times your RPM you're running, divided by 3.82. It's pretty much just the opposite of what the RPM was. Chip load in inches per minute is mostly for milling machines, end mill. Basically, you know a chip load, say you want it to be a 2,000 chip load per tooth. You would take your inches per minute divided by RPM multiplied by number of flutes. Easy, that's what chip load you're running. Okay, so if you want to know the inches per minute you want to run with a chip load that you've designated as 2,000ths a chip or a flute, you would take RPM times number of flutes times the chip load you want to run. That'll tell you how many inches per minute to run. Very easy. This feeds and speeds one. Basically, on a manual machine, you cut to what feels good. These numbers are really nice for the CNC guys. You basically pick a 400 surface feet per minute for the carbide tool, 100 for the high-speed steel. You do the calculations, you plug them into the CNC, the feed and speed and the RPM you want, and boom, it's a good starting spot. Okay, here's another simple one that you're not going to use very often. It's basically how to calculate the degrees of a taper. Say you have an existing taper, you want to match it. You take large diameter minus the smaller diameter divided by the length of the taper divided by 2, which will give you the the angle from the center to the edge, not the included angle, divided by 0.0174. That's what equals the degrees. An example would be, say, a Morse taper number 3. The big diameter is 938 minus the small diameter, which is 7.78, divided by the length, which is 3.190, divided by 2, which will give you the single angle from the center out, divided by 0.0174. That's what equals the degrees, and it works out to 1.441 degrees. Pretty easy, pretty simple. So, in other words, if you were to cut a number 3 Morse taper on your lathe, you'd set your taper attachment to nearly 1.5 degrees, or a little under 1.5 degrees, and you'd start from there and you check it. Or your compound, you set your compound to a little under 1.5 degrees, and it gives you a good starting point. These cheats here, this information is nearly invaluable, but I'm not sure how to put this on YouTube. I scoured the internet trying to find these, and I couldn't find nothing to tell you where to go. Basically, this is bolt circles. All these are dimensioned out with a 1-inch bolt circle, and they give you a dimension from the center to go to. All these, and whatever bolt circle you're doing, you multiply that diameter times these, and that gives you how far you go. I'm not sure how to put these on eBay. If you got any suggestions, let me know. It goes from a 3-bolt pattern all the way up to a 12-bolt pattern. I might try taking still shots of these, and hopefully they come out clear enough, and I'll put them on YouTube, and you'll either have to draw them out yourself or print them out off the computer or something else. Well, that's it for now. Hopefully some of this will help you people. Well, hopefully some of these will help. I know they've helped me over the years. You know, the taper is one you don't use hardly ever. The feeds and speeds I use constantly on the CNC work. This one I don't use often, mostly at home whenever I use it, and bolt circles I haven't used in years. This works best with a set of digitals on your milling machine, and some of the digitals actually have calculating bolt circles on them, but you don't even need this anymore. I'm still going to tinker around and try to figure out a way to get this on there so I can show you. It's really helpful. So that's it for now. Maybe in the next video we'll talk about some lathe work. See you later.